Good morning. So before I start, I'm gonna talk about a sort of fairly narrow and specific part of a project, which is much broader and more multidisciplinary. So these are my collaborators. You'll recognize most of them here in the room. I'm a sociologist by training, so I'm going to focus on some very strictly sociological problems. In the case of using shared elevators with robots. Now, a lot of the talks, and we didn't set this up deliberately, but it worked out quite nicely, in this session have focused on the desire to get people interacting with the robot. And in a way, we set up, our design philosophy was the opposite. We really sort of started from the assumption that you wanted to create a very simple, very smooth and non-eventful interaction. And the truth is that sometimes you need that when, I mean, not every occasion of interaction can be an occasion where you know, dive into each other's mind with every person you interact. It's too much. I think with robots, the more pervasive they become, the more that problem is also going to exist with robots. In a service scenario in particular, if you have you know, 50, 100 robots running around your building, and you're running into them all the time, then you don't, like, you can't sort of emotionally connect to the robot every time every time that happens. And from a service design point of view, you want to give the service provider the option to decide that they want to have an unobtrusive service. It's also in the nature of the scenario itself, because taking the elevator is a non-event. Really, and we wanted to preserve the non-event character of taking the elevator. Now, of course, then the question methodologically and technically also becomes how little can you get away with in terms of the robot's interactivity and communication in order to still have a smooth interaction, because taking the elevator is still a social event, and with its social norms and social rules that sort of articulate the way it happens, and the robot has to blend into that competently. So I'm going to go through some of the challenges. I'll just wrong way. I'll just start with a little bit of a methodological plug. Like Matt's yesterday, I also come from ethnomethodology. There's a sense in this particular form of sociological analysis that the sort of social order is an ongoing accomplishment. What that means is that the elements of the interaction, I'll talk a lot about proxemics and gestures, but those things, the meaning is not necessarily intrinsic. The semantics of a gesture or of an interaction, and it's true of language as well, of a word doesn't lie in the word itself or in the concept, it lies in the flow of interaction. And this is something that ethnomethodology have traditionally focused on. Sorry, there you go. In doing that, the point is to try and sort of describe what this machinery of interaction is that determines how taking an elevator as an occasion of interaction happens and happens smoothly. I say it's sort of the machinery of interaction provides its own generalization, and if you think about it, once you know how to take an elevator, then you know how to take an elevator. You don't have to relearn it every single time that you do. And this tends to apply also pretty cross-culturally. Maybe that's just the nature of elevators, that it's a quite simple simple interaction, and then that's because the social norms and the competence that we have to navigate that social context is a competence that you acquire and then you have. So sociologically, the interesting part is trying to describe what that competence is, break it down to see if you can also teach it to the robot. And this is where things become complicated, conceptually and methodologically also, because formalization is not, you can describe formally what the rules of taking the elevator are, but that doesn't necessarily tell you how you should follow those rules in any given situation, which is why ethnomethodology typically is not in the business of formalizing. You describe, but you don't necessarily formalize rules to a social situation. The problem is that if you're dealing with a robot, you kind of need you need a formalization or rules in some form, because otherwise you have nothing to give the robot. So for that we sort of turn to more proxemics and sort of interactionist approaches to give a sort of an architecture or a formalization to the things that we observed, hoping to be able to sort of teach that to the robot. So I'm going to show you some videos from an experiment we did, and I should point out that this sort of theoretical structure using proxemics is something that we started working after we did the experiment. And if we started working on it before, maybe I wouldn't have as many errors in the experiment to show you. But that's kind of the nature of this type of research, and also the importance of putting people in a sort of naturalistic situation with a robot and see what happens when they interact in a particular scenario, and then you sort of realize what's missing in your analysis of the situation. So if some of the things seem obvious that I'm saying, then bear in mind that with hindsight a lot of things do seem obvious, but beforehand not necessarily. So we designed very simple gestures for the robot. There's basically two gestures. One is a stepping in gesture if you want the robot to take priority when getting into the elevator, and the other is a stepping back gesture if you want the robot to yield. And we had two different ways of positioning the robot when waiting with a person for the elevator. One we called machine-like, because it was always the same position, right next to the door, you'll see in the video. And the other that we called human-like, which is a more flexible position. So that's the structure of the experiment and all the different sort of permutations of the task that we had the robot perform with the participants, and sort of use the gestures to either try to give or take priority. And you can, if you're interested, there's a paper that also won a Best Paper Award at HRI 22. So a little bit more about the types of proxemics that we're looking at. We use the notion of transactional segment. I'm sorry if people are already very familiar with proxemics, but it's a sort of it's a social space between yourself and something. It could be a television, for example, and then you know that the space between you and the television is a space that you normally wouldn't want to intrude, and you know that because of the orientation of the body, the posture, the eyes, just your understanding of the social activity, that there is that space over which that person exercises some kind of control. Now, when you have a shared social activity, then you can actually sort of have a shared space with shared control and then you have what they define as a sort of transactional space. And maintaining that space is a very dynamic, as we'll see in the videos, is a very dynamic process, which requires a certain amount of, if not collaboration, because it's not always particularly collaborative, then situational awareness and coordination of each other's body language and gestures. So again, yes, posture and orientation are very important. Now, I'm not going to go into the distinctions between a lower body and upper body orientation in the videos, because we're also working within the limits of the technology platform that we have. First of all, the robot itself does not have an upper body and the lower body. And also, it's not clear whether perceptually you can see the whole person. At the moment in this experiment, the robot doesn't see a person at all. It just sees obstacles, but that's the next step. So how does this impact order of service in elevators? These were videos that we took at NAVER Labs in Korea. And it's sort of, first of all, it's the importance, like I was saying, with the transactional space. It's not just between people, but it's between people and the space. So in this case, the elevator doors, obviously, are extremely important. And here you can sort of basically see two very different situations. The one below, what you have is essentially two transactional segments, because you can see from the posture of this person that there is no orientation towards the other person waiting for the elevator. Whereas these people are sort of clearly more oriented to each other than they are to the elevator doors. This means the difference between these two situations is that in one situation, there might be room for some renegotiation of who goes first inside the elevator. And in a situation like this, really probably not, which matters if that's what you want to do. Yeah, so this is just, before I go into the videos, this is just the setup with the two different waiting positions. There's two, I have two videos in this part to just highlight two elements of establishing a good transactional space with a participant. One is orientation of the body, so the angle, and the other is space, and in particular the distance to the doors. And both matter, and both can make the difference between a successful gesture and one that doesn't work. So this first video sort of highlights the importance of orientation. And so you can see the, you don't have to read the text track if it gets confusing, but you can see sort of the, this is not a good positioning, and I know it seems obvious, but you can see that the robot is really sort of facing more the person than the door. So even though the attempt to angle yourself at a sort of 45 degrees, so obviously when the robot sort of steps in to take priority, it's not doing it that into the transactional space, it's doing it into the person. So it doesn't work, and obviously the person is going to move out of the way. At this point, it's not even a question of whether the intent of the robot was perceived correctly or not. I mean, I would argue not, but so in this sequence, you can see that there's two consecutive trials here. Now this is the machine-like positioning, and this is really more the problem. There's a question of space, because the orientation is not terrible, but there's very little space. So there's probably also an issue of timing, but the stepping gesture, you see, there's not space to go in deep enough so it sort of, you know, it stops where the robot runs out of space and the guy just, you know, just goes ahead. Now, the second trial is interesting because he's standing slightly further back. Also seems to have a more sort of awareness of the presence of the robot. Body language is very subtle, so you could spend hours interpreting everything from the movements of the head. But so again, the space, in this case, the space makes all the difference because there was that transactional space for the robot to step in. The problem was that the angle in this case wasn't good because when you position the robot in that place, which was the machine-like positioning, then you have a sort of a 90-degree angle with respect to the transactional space and the doors, which means that when you're stepping in, you're completely cutting across a person's body, and that's actually a fairly aggressive gesture, and maybe not necessarily one that the participant expected the robot to do. So in a sense, the gesture works here because the robot gets in first, but socially this is not a smooth interaction. Now the other element, which is extremely important and maybe even more complex technically with the robots, has to do with the timing. I'm not going to go too much into the detail of the difference between these types of scenarios, although it does matter because when you have more than one elevator door, people tend to stand further back and then wait for some signal that the elevator doors are going to open before moving. So when you're looking at the proxemics of this type of situation, analytically you can divide the sort of the different postural configurations in different phases of the social encounter. So in the case of an elevator, you have sort of approach, waiting, and entering. And the interesting part really is the transition between waiting and entering, because that's really when the order of service is resolved, and that's where the opportunity for the gestures, for the non-verbal gestures to take place is. But the timing of that transition is determined by whatever the nature of the interface of the elevator is. In our experimental setup, it was simply the fact that the elevator doors were transparent. And so that people could see the elevator arrive and they knew when it was about to open. In this situation, you have flashing lights which indicate which elevator is about to open, and then people just sort of move towards it. Now, in NLK, the robot is actually connected with the elevator infrastructure, so it's possible for the robot to know when the elevator is arriving, but I'm not sure. It's a question that we will have to discuss, is how synchronized that signal is with the signal that the people are responding to, and the timing is really important. So this last video that I'm going to show sort of highlights, and I'll just show you the video. This is a yield gesture. Now I want you to just pay attention to the guy's hesitation. Now it's not a big deal. The situation resolves itself the way you would want it to, but what that hesitation tells me is that the intent of the gesture was not perceived at all by the participant, because otherwise you wouldn't hesitate. And the problem, and again it's very subtle, but the problem is timing, and the problem is that basically the gesture happens too soon with respect to the elevator doors arriving and an opening. On top of that, and I didn't show you other parts of the video, but when the robot arrives and positions itself, the robot's positional adjustments are hard to distinguish from the yield gesture. That's just maybe a limitation of the way this particular robot was moving. But it's also, again, it takes me back to what I was saying about gestures not having an intrinsic meaning. It's situational and it's within the flow of the interaction. So if the gesture doesn't follow the flow of the interaction, then its meaning gets lost. So the question is, what does the robot need to understand? The sort of segmentation of available space, so the ability to recognize a threshold or a door, seems to be quite important. And obviously the intentionality of postures and gestures, but like I said, that's where this starts getting complicated, because that's really sort of embedded in the flow of interaction. So maybe it's not enough to, you can't just specify particular angles or particular distances that the robot needs to use. You have to have a bit more situational awareness, and how we go about doing that is something that we're starting to discuss. This is what I was just saying. It's sort of relative to the flow interaction, but also relative to the elevator doors and the configuration of the elevator lobby. There's no distance that in absolute is too close or too far away. You kind of have to adjust yourself to how other people are positioned, and be able to readjust yourself. Yeah, that I already said. So I don't know how I'm doing for time. I feel like I just blazed through this presentation. So I'm kind of done. Before I go, I'll leave you with just to say we're not just putting problems out there. We're also looking for solutions. So this is a technology that's being developed at NLE, and you have the reference there as well, if you want to sort of, and this is a trial experiment of sort of putting the pose and posture recognition and prediction potentially onto the visual perspective of a robot, and in this case you can see also that the perspective is not a particularly complete one, and so whether this is enough. This gives you all the information you need in order to position yourself properly in this scenario. I don't know. This is something that we're only just starting to think about how to move forward with. So yeah, that's the presentation. Thank you, and I'll see you during the panel for questions.